All right, so let me give you an overview. So we have two trees in scope. Uh, we have this core lending contracts, and in those we have everything in the source folder except this periphery contracts. And these are lending contracts that we are extending the Euler V2 protocol, uh, and we are allowing any curator on Euler V2 to now accept Uniswap V3 and V4 liquidity positions as collateral. Um, and then second repo scope is this Uniswap V4 hook, and in that the scope is the source folder all of the contracts in this except the periphery contracts. And this is an independent system. It's a Uniswap V4 hook that allows liquidity providers to earn swap fees on top of interest from any lending protocol as well. So the way that these two are connected is that the Uniswap V4 we have this Uniswap V4 wrapper that supports any vanilla pool that doesn't have a hook, and it also supports uh, the Uniswap V4 pools with this yield harvesting hook that we developed enabled. So that's how these two are connected, but otherwise, like it's two independent separate systems. So that's an overview. Okay. So let me go deeper into how the core lending contracts work. Uh, hi. So let me just take you through maybe the borrow flow. Um, we will take Uniswap V3 as an example, but you can imagine it's almost the same, except a specific core logic. But otherwise, the all of the interaction should be almost similar. So let me just take you through a normal. Uh, let's say that there is a specific a normal Euler USDC vault. This will be a vault that is developed by Euler team, and it accepts other ERC20s as collateral. And against these ERC20s, this Euler USDC vault would let users borrow USDC from this vault. Now we are extending it so that against Rapid USDC Uniswap V3 liquidity position, uh, this USDC vault will allow users to borrow USDC. So that's how it differs from the existing Euler system. And the Euler system, it on top all of this is built on top of Ethereum Vault Connector, which handles all of the authentication related stuff in Euler. And so that's why it was easier to extend Euler protocol to add this custom feature, which is essentially this Uniswap V3 liquidity positions are NFTs. So we are now accepting this NFTs as collateral in an existing lending protocol. So let me just take you through a simpler this whole borrow flow, where a borrower would mint like add liquidity into Uniswap V3 pool, and using this if they do it using this non-fungible position manager, it's a Uniswap V3 periphery contract. They get an NFT representing the liquidity position. So this Uniswap V3 wrapper um, that we have, it recognizes this NFT as a collateral. So user would out of user would mint this NFT, but it won't be like uh, at that point user wouldn't have interacted with any of the 7 finance smart contracts. They would have access just this NFT in their in their wallet basically. And then if they want to use it as collateral to borrow USDC, they would call wrap function on our Uniswap V3 wrapper contract, and then call enable token ID as collateral. So let me take you through what this wrap function does. So this wrap function, yeah, it takes the custody of NFT. So the wrapper would now have the NFT and it will mint representative ERC6909 tokens to the user. The 6909 token standard is like similar to how ERC1155 works. And when user wraps, they get minted full amount of ERC6909 tokens of that specific token ID. So now user would have this 6909 token representing their collateral in our wrapper, and then they would call enable this token ID as collateral. So this is a necessary step to so that wrapper would now recognize in user's balance. It will now recognize this token ID token ID's value. And so after wrap and enable token ID, they can now go to an Euler vault that accepts this Uniswap V3 wrapper as collateral. It asks to borrow some USDC. This Euler vault always interacts with US EVC, and EVC asks Euler USDC to this vault to optimistically just allow them to borrow. Uh, so the Euler vault would transfer the USDC to the user, but then at the end, EVC makes sure that this check account status check is triggered in the corresponding in the Euler USDC vault, and this check account status um, would make sure that user position is not underwater. So for that, Euler USDC vault needs to it knows how much user has borrowed, but it doesn't know how much collateral it has. Um, One of the collateral would be, of course, this Uniswap V3 wrapper. So it will ask the Uniswap V3 wrapper how much borrower's collateral is worth. And then the Uniswap V3 wrapper, based on the 6909 token balance, it will return how much total value of collateral a user has. So this we have configured it so that up to 7 token IDs are allowed to be enabled as collateral. And so it will loop through all of the token IDs. It will calculate the value of token ID based on whether it's Uniswap V3 or V4. And let's see, if it's Uniswap V3, based on the token ID and amount, it will calculate how much the, how much to underlying tokens, how much this token ID is worth in underlying tokens terms, and then it calls the oracle and converts this amount into a unit of account, which is usually USD. So it converts the underlying tokens into USD amount and then adds it up and returns it to the Euler vault. But because this Euler vault is always interacting with other ERs, like it was configured to be interacting with other ERC20s, it still asks the Oracle whatever the uh, our Uniswap V3 vault wrapper return. It doesn't know that it is in USD terms, so it still asks the Oracle to convert it into. Sorry about that. It still asks the Oracle to convert it into USD terms. We will configure the Oracle to be a fixed price Oracle so that it always returns one gem one. So uh, it just returns the same amount, and now the Euler USDC vault knows how much the collateral is worth, and based on the LTV and the borrow value, it will make sure that if Alice is underwater, then it fails, and if it isn't, then it succeeds. So that's where the EVC, if the Euler vault gives all okay, then that's where the process ends and the borrow is done. Right. So user has borrowed, so they have wrapped and then enabled token ID as collateral. They can choose to do some stuff that decreases their uh, collateral value, like disabling entire token ID as collateral. In that case, like whatever the value of this token ID is, that's how much their position will, their collateral value would decrease by. Or they can choose to unwrap, like partially unwrapped. They can choose to unwrap the whole NFT, or they can choose to unwrap partial NFT. In this case, if this is a entire NFT being unwrapped, then your user would get the entire NFT, and and if it's partial unwrapped, then they would get just a they would get proportional underlying tokens. So this unwrap function would have specific implementation based on whether it's Uniswap v3 or Uniswap v4. But whatever the action is that decreases the collateral value, we have to make sure that the account status check is being done. In this case, it's being done here, but if it's unwrap or partial unwrap, it is being done in the when the update function is overridden. So yeah, the check is being done here. So we know why balance of function exists. So when we let's talk about how the liquidations would work. So Euler vault, it determines how much. Let's say Euler vault has determined that the collateral value has decreased, uh, uh, and the account is now liquidatable. So the Euler vault would ask our collateral, uh, this collateral wrapper, to transfer some amount of um, uh, positions equivalent to some USD amount from the violator to the liquidator. So in that case, uh, we will loop through all of the enabled token IDs and proportionally transfer the ERC6909 tokens from the violator who is underwater to the liquidator. So that's what this function is for. It simply transfer the 6909 tokens, and as we know, 6909 tokens, it represents claim to the NFT. So the liquidator can then call unwrapped to get the underlying tokens back. Right. So that's it. That's the overview of how the lending contracts work. So let me just go through the differences between units of V4 and V3. Yeah, so in this case, for Uniswap V4, the underlying NFT would be the position manager, which is the Uniswap V4 peripheral contract. And the main difference is the position manager. It doesn't handle the pending fees. So the non-fungible position manager, a uh, the Uniswap V3 contracts are the non-fungible position manager is constructed so that the fees they are always stored in this token owed. If pending there are pending fees that are yet to be claimed and a sync happens, then those fees get stored in tokens owed um, mapping. But in Uniswap V4, the position manager forces you to always, for any, either it's adding or removing liquidity, it forces you to always claim the fees. And because there can be multiple 6909 token owners for a specific token ID, we cannot just distribute whenever there is a partial unwrap, we cannot just distribute all of the fees to the user. So we have to maintain this tokens owed. Uh, uh, we have to maintain this state ourselves. So that's the main difference between the Uniswap V3 wrapper and V4 wrapper structurally. Mm, I don't think there is anything else that I want to highlight. Yeah, one thing that I want to highlight is there is this attack vector in Uniswap V3. In Uniswap V3, the non-fungible position manager allows someone else to add liquidity even if they don't own the token ID. So if someone has wrapped the token ID into our Uniswap V3 wrapper, the token ID will be the NFT would be held by the contract, but anyone else can increase the liquidity in that token ID. So what a user like an attacker can do is uh, just wrap an LP position and then enable it as collateral, but then unwrap all but one way of ERC6909 token, and then they can borrow against or um, they can borrow against it and then make like use the non-fungible position manager to increase the value of this liquidity position to a very high amount. So this one way of ERC6909 token would be worth a lot of collateral, and we have taken care of it by always rounding in favor of the liquidator. But if you find some attack vector where an attacker can take advantage of this attacker like this, it would be great if you could find an attack vector. Like I have created this this POC. You can finish the exploit basically. Like if you can't find it, like then we would assume it is safe. Uh, but yeah, this is what I wanted to highlight. All right, so let me just go through the yield harvesting hook. It is a Uniswap V4 hook for any yield generating vault, like uh, let's say ERC4626 vault or Aave like a rebasing token. We support both. We wrap those underlying vaults into this vault wrapper, and the pools are created using these vault wrappers. And whenever there is let's say interest gets accrued, uh, um, this before anything happens. Let me go. before any action happens, let's say adding liquidity or remove liquidity, or before a swap, we harvest and distribute the yield. So what we do is we get how much the pending yield is, and we donate it to the current liquidity providers, and then we uh, so what happens here is, if this was not the case, like if we were not wrapping an underlying vault into this vault wrapper and then using this hook, uh, let's say we created uh, let's say we created a vanilla pool using these underlying vault tokens. Then what happens is this yield generating vault tokens, its value gets increased, even if no trades happen, because uh, they generate yield and its value increases. And this value, it increases at different rate for each of the tokens. So all of the difference in the yield, it usually gets um, taken away by the uh, arbitrageurs and the liquidity providers. They don't benefit from it. So this is a hook that helps with that, and it's much simpler than the gold lending contract, but still important. So this is the main entry point where uh, given underlying vaults, this is the 4626 vault wrapper factory, and given underlying vaults, it wraps them into these vault wrappers, and then creates a pool between them. And in that pool, as I said, um, it's always initialized with this hook, those pools, and in those pools, before adding liquidity or remove liquidity or before swap, this harvest and distribute yield gets called. And we have this smooth yield vault, which is a helper. It's a helper contract to make sure that uh, the yield. Eh, so for lending protocols, we know that uh, uh, the yield gets distributed smoothly, as in like it gets distributed continuously every second. But for rebasing tokens like STEs, the yield is distributed immediately every 24 hours or so. And this is a wrapper, so um, if you provide a token like STEs as an underline for the smooth yield alt, it will make sure that whenever the yield is distributed in the underlying token, it is only reflected in this smooth yield vault continuously. So that's what this helper contract is for. And in this, what I wanted to highlight is that this ERC4626 vault wrapper, it doesn't support the bad debt socialization. Um, so if the underlying vault share price drops, then this vault may become insolvent. So we do not support any lending protocol vaults that have bad debt socialization enabled. That's what I wanted to highlight.